Hello and welcome back. Today we're going to talk about T2 and T2 star contrast. So what are the differences between these two types of T2 contrast? Well, they both are T2 weighted, which means that fluid will be bright on both of these images. But there's got to be something different between the two because we represent them differently. And the T2 star is an image that has inaccuracies in the T2 contrast we collect from our patient. And in order to understand this, we need to understand this T1 component and T2 component. So I'm going to do a quick summary of that. If we go ahead and draw longitudinal magnetization recovering over a period of time, we have T1 contrast. We know that if we excite our patient, we go ahead and lose our longitudinal magnetization, and over a duration of time it regains, and then we deliver another RF pulse, and this drives down our signal, and we start over, and this happens over and over again until we get this steady state of longitudinal magnetization that we encode in our image. But at the same time, as we lose this transverse magnetization from one RF pulse to the next, or a given TR time, we're also increasing the transverse magnetization in our image. The transverse magnetization over a given period of time, we increase that and lose that very rapidly. When we go ahead and give another TR, we shift those protons in the transverse plane again, lose that signal, so on and so forth. Now, something interesting happens. If we're looking at this decay of transverse magnetization, or T2 contrast, we want to understand that after every TR, we're losing this transverse magnetization, and we call that free induction decay. So I'm going to just go ahead and erase this for now, and write free induction decay. So we get this free induction decay in our image. And free induction decay is essentially this decay of transverse magnetization that is dependent on neighboring protons and the uniformity or homogeny of our magnetic field at isocenter. So how uniform is this magnetic field, and where are those neighboring protons in relation to each other? And since those two situations vary after every single TR iteration, the decay, or free induction decay, is going to be different after every single TR. So I excite my patient, I get all this transverse magnetization, I get free induction decay. I go back and excite my patient again, I get free induction decay. I excite my patient again, get this transverse magnetization, I get this decay. Now, if this happens after every TR, we know TE controls T2 contrast. So if I go ahead and put a TE at a given period of time, and I collect all my echoes at that period of time, I can see that there's lots of variation between the decay of my transverse magnetization. And that's going to lead to variations in that T2 contrast that I collect. And that's the reason we call this T2 star contrast, is because it's not completely accurate. But what we can do is we can implement something else, another RF pulse, a 180-degree refocusing pulse. And what happens if we go ahead and do that is that we can get this transverse decay after excitation, and if we deliver a 180-degree RF pulse, we can regain that transverse magnetization again. And sample a TE at our peak signal. So we're getting this free induction decay, I utilize a 180-degree refocusing pulse, I regain phase coherency, and I get my TE time maximum signal, and I take a sample at that time. And I can do this multiple times and create an image of these TE times that we've sampled as the signal is decaying and create a more accurate representation of what's happening to our transverse magnetization. And this leads to true T2 contrast. It's more accurate than using just free induction decay. And the difference that we see these in is when we run a gradient echo, we don't utilize this 180-degree refocusing pulse. What we're utilizing instead is just our 90-degree excitation pulse or less, and sampling free induction decay, these inaccuracies. And that leads to T2 star contrast when we image using gradient echo. But when we use spin echo sequences, we're utilizing a 180-degree focusing pulse, which allows us to get true T2 contrast in our image. And that's essentially the difference between the two. When we use 180s, 180-degree focusing pulses, we're going to get true T2 contrast. When we don't, we're going to get these inaccuracies represented in our image, and that leads to T2 star contrast. Thank you so much for watching, and I'll see you next time.